Okay, today I want to talk to you about graphing absolute value inequalities. So, I'm going to start actually with graphing two variable inequalities because it is almost exactly the same as what we have been doing. Okay, so last two assignments we worked on graphing things like this, and we learned that they are these V-shaped graphs. That can be moved around by adding or subtracting to different parts of the equation, like so. Hopefully that all is familiar at this point, right? Things like that, okay? So, graphing inequalities that have absolute value is exactly the same. The only difference is we shade the regions where the solution is. So, for example, this is the graph of y equals the absolute value of x. So, where y is greater than is just a region of coordinates where the y part of the coordinate is bigger than the x. Alright, and that's just going to be anywhere above this line and that line. Okay, and this is different from the graph of just y is greater than x, because that would just be this, right? All of these would be solutions there because these negative x values, like y is like a larger negative, or a smaller negative, which means a larger value here than the x is. So these would have been true for this, but because that graph of the absolute value of x doesn't go into negatives for the y, all the values over here are going to be positive. It's reflected back up, and the only points where y is greater is where the actual number for the y part of the coordinate is larger than the number for x. So, for example, you might have a coordinate up here, like -1, 3. Clearly the y value is larger than x, or something like this. That might be 2, 3. And you can see again the y value is larger, and all those are going to be solutions, but something over here, like -4, what is that going to be, like 1, is not going to be a solution because it's going to end up being the absolute value of -4, which will become 4, and that is larger than 1. So that's why these are not solutions. Okay, so the shading for this is just above the line, works just the same as shading other inequalities, except you've got lines going in two directions, so you have to think about shading just above it, okay? So that, I think, should be very straightforward because it's so similar to what we did yesterday. All you have to do is figure out where to shade and remember if your line is dotted or solid. The thing that's actually harder, I think, is graphing absolute value inequalities with only one variable. Okay, because there's a little more to remember. Alright, so if you look at this, you can probably see there's going to be a region of solutions, and that solution region is going to extend both to negative infinity on the left of your number line. It's a number line because there's just one variable, and it's going to extend to positive infinity because if you put negative infinity in here, this will become positive infinity. If you put positive infinity, it'll become positive infinity. So either way, it's going to be greater than 4. So we know that out here is, yes, makes it true, it's a solution. But there's going to be a spot in the middle where it's not. Okay, so we have to figure out where that is. And the way we do it is to do exactly what we've been doing. We solve the absolute value as if it were an equation. Okay, so I'm going to make sure it's the absolute value portion is isolated. In this case, it already is. So I'm ready to begin. And then I'm going to split this into two separate inequalities. The first one is going to be just as written without the absolute value, x plus 1 is greater than 4. Okay? That's the case where this is positive, where the absolute value doesn't actually change anything. And the other case is where this is negative, but there's an extra step to change the direction of the inequality. And that's essentially because you're multiplying this portion of the inequality by -1, and when you do that, the direction of the absolute value, the direction of the inequality changes. Okay. So graphically, this is pretty easy. I'm just going to solve for x, so it's a little easier to see. It's just like we expected. There's going to be a point here at 3, and it's an open circle because it's greater than, and a point here at -5, and that's also an open circle because it's less than. And anything bigger than 3 is a solution, and anything less than -5 is a solution. You can test that. If you want, you can plug in something in the middle and make sure it's false, like 0. 0 plus 1 is 1. 1 is not greater than 4, so that's good. You can plug in 6. 6 plus 1 is 7, which is greater than 4. That's good. You can plug in -10. -10 plus 1 is -9, which becomes 9. Greater than 4. That's good. Okay? So that is graphing absolute value inequalities in one variable. Now, that was a greater than. Let me show you how it works when you have a less than. Okay? So, if you look at this for a minute, you might realize that there's going to be another region of solutions, but instead of the solutions being on the outside, this time the solutions are going to be inside 2 points. And that's because the absolute value has to be less than something, and we know that absolute value can go to infinity, with this being either a large negative or a large positive. So the limits of our graph are not going to be a solution. So it's going to be some region in the middle that is. All right, we can figure that out just the same way. Make sure the absolute value is isolated. In this case, it already is. Split it into 2 inequalities. The first one, you just leave it exactly the same. Get rid of the absolute value. That's the case where this is positive. And then you have to figure out what happens when this is negative. And that's going to be rewriting it, but with the the inequality direction changed, and the right side multiplied by -1. Okay? So now we just have to graph both of these. Now I should mention, I got this in the previous one, the connection between these two statements changes depending on whether it's less than or greater than. And that, I think, should make some sense, right? Because in the other one, it could have been less than the small part or greater than the larger part. But in this case, it's not like it's less than 6 or it's not less than 6 or greater than -6, because that would just be everything, right? Everything is like greater than some negative number and smaller than some positive number. So instead, we connect this with an and. The other one was connected with an or. So you got to keep track of that. Less than is and, greater than is or. All right? So let's just solve these for x. Makes it a little bit easier to graph. And we'll find our points here on the number line. 0 is a little bit closer to the 5. I'll put that in there. And then our solution region, these are both open circles, is just going to be in between. All right? And if you're not sure, you can test it. You can test 0. 0 should be a solution in this case. So 0 minus 1 is -1, becomes +1, but still less than 6. So that's good. You can test 10. 10 should be false. 10 minus 1 is 9. 9 is not less than 6. So that's good. That's false. We can test -10. -10 minus 1 is -11. Becomes +11, which is not less than 6. So it looks like our solution region makes some sense. Okay? Now, that's all pretty straightforward. I think if you remember how to solve your absolute value equations, solving your absolute value inequalities should be basically identical. The caveat here is that when you get more complicated equations, and I don't think I'll assign too many of these, it can be tricky to keep track of the direction of the inequality. So for example here, in order to isolate this absolute value part of the inequality, we need to multiply or divide by a negative. And you have to remember that when you do that, the direction of the inequality sign changes. Okay? So this will change from a greater than to a less than when you solve for this portion. All right, and then you just go through the same steps. This is almost identical to what we just did. But this is a good example also of another thing that can happen. Okay, so this will be x is less than, oh no, never mind, it's just like the other one. I was thinking something else was going to happen. I didn't change the direction. So. Okay, so because this is a less than, that tells us that there is a, hang on a second. Yeah, sorry, that tells us that it's an and. There's a region of solutions it's in the middle of. 2, -2. No, I did that wrong. I'm like, wait, that can't be 2. Okay, sorry. So this is 1. I was supposed to subtract 1 and I added 1. That's a mistake. Okay, so it's less than 0 and greater than -2. That looks better. Got it. Okay, so if that's true, we should be able to plug in -1, it should work. So -1 plus 1 is 0, 0 is less than 1. Looks good. Alright, so that's that. Don't forget about the changing direction of the inequality when you multiply by -1. Now there is one other thing that can happen, which is you can get things with no solution. Of course, the obvious one would be something like this. Let's see here. Oh no, that's not. Because of course we know an absolute value can't have a negative value, so there's no way this can ever be less than 3. There's just no value that's going to make that true, because this is always at least 0, and there's no way 0 is going to be less than a negative, all right? So that would just have no solutions. Okay, and then you can wind up with things that have infinite solutions. That would be very similar. This would have infinite solutions because all absolute values are greater than 0, which is greater than -1. So this would just be, you could write all reals, or infinite solutions, whatever you want, or you can just make a full number line if you like doing that. Those all kind of mean the same thing. Okay, that is the lesson. I look forward to your questions.